Good afternoon, everyone. 那因为我们大部分的与会者呢都是讲中文的，所以呢，今天我的报告会用中文来进行。如果大家有什么问题的话，可以来问我，我会很高兴回答各位的问题。Good afternoon, everyone. It is my pleasure to be here with my colleague Tong. We are from JDcom. And it's my honor to be here to share about our experience in serverless. Firstly, I think most of our peers are aware of JD.com, but I want to emphasize that we are a very large company and we have very rich application scenarios and we have a very large customer base. In addition to traditional e-commerce business, we also have a business in the logistics and the financial business, and it is also in the IT platform, and we have cooperation with large internet companies. We have the strategic partners with these companies, like Google, Walmart, and Tencent. They are large partners. And I want to introduce our team. I don't know how many of you attended the keynote session this morning. And JD.com just won an end user award. And I think it is a recognition from the community. And I think from the JD.com's containerized platform and also I think JD is one of the earliest company using this technology. And in 2016, I think Google started to make the Kubernetes open source in 2015, and I think many platforms are working on this containers platform. And there are many competitors like Docker and so on. And in 2016, we think that Kubernetes is a technology that will be very potential in the future. So we use the Kubernetes. And now, I think we are one of the largest Kubernetes and the containerized platform. We have tens of thousands of containers which supports our business, including the shopping day, and also we have cooperation in the logistics and the financial businesses. And I think we have achieved a certain stage in the major businesses. So I'm very glad that we joined the CNCF today, become member of it, and we can have more participation in the community. I think as an end user, we have gained a lot of benefits from the open source. Many of our systems are based on those source, and in our practice, we also contribute to many use cases and also the future. And so we have made contributions to the Kubernetes and also the system. And I hope that in the future we can have more exploration, and we would like to share our experience as an end user to the community. And the most important is that we can have a contribution in technology. I think the serverless is also a new area, and we are exploring how to make the most advantage of it. As I mentioned before, that this is a very technical part. I don't know whether we can turn off the light to make you have a clearer view of the PPT slides. It seems that the room is too bright. Okay, I have made a summary that we are a containerized platform, and Kubernetes is just a core of it, or the OS of the containerized platform. But actually, we established and set up many other softwares on top of it, with the and actually we have containerized infrastructure. I think this is a platform for the infrastructure service. And we also have JDOS, and this is optimized Kubernetes of the JD, and we also have the managed system and also the middleware, RPC, and caching and other database. All of these are running on our container platform. In addition to the online business, we also have the AI and big data analysis. And recently, we also have offline stores. And we also use this kind of technologies for our offline stores. As I mentioned, we apply these technologies for all the businesses in JD, including the international business like in Thailand or the Indonesia and other countries. And now I have introduced a lot of background. So I hope that you will know the current context about the JD. That is, JD has a very large containerized platform. And in this condition, in this context, I don't know, do, do you have a very good knowledge of the FaaS? If you do, please raise your hand. Well, many of you maybe not know a lot of it. I'll give you a brief introduction. That I think it is I'll just give you a brief introduction. And if you take a high-level perspective, and from traditional big application to a small services, then can we divide it to even smaller units? And I think its model is driven by the message and the service. And we will consider it from two aspects. I will mention why we pay attention to it. As I mentioned that in JD we have very rich user scenarios. So the function services are driven by events, and they want to have smaller services. We can find a specific user scenario, no matter from the back end or from the big data analytics or even the edge computing or IoT. We have this kind of scenarios, and also it is suitable for the timer and for the scheduling. I think it is very useful, and it is very commonly used in the data handling. Why we pay attention to it? Because maybe we can find function service or service computing scenarios in JD. We are very interested in this direction. And secondly, I want to talk about why we want to do it. As I mentioned that I think the function service or services is based on the containerized scenarios. And as I mentioned, we have very excellent platform to support the container and also the Kubernetes system. Therefore, we have a very solid foundation. And as I mentioned, from the traditional big application to the microservices and to further even smaller functions, then I think it will provide a lot of opportunities in the resource elasticity and also the resource scheduling. And for example, if we now have the fragmented resources like about half a core, maybe the granularity is not small enough. You can't distribute it further, so there will be some waste. And if we can have an approach to make use of this half a core, then it will be better. And also, if you don't want to use it, then we can just put it at idle. And from the perspective of the business, I think the function service service will bring some benefits from two aspects. Firstly, from the perspective of the user, I mean, if you are writing the application and you want to deploy it in a container, of course, today you can use the Kubernetes. But of course, the complexity is still very high, and the keynote, you know that the threshold is still high. But if in your application you have a template to follow, then you can simplify the process. You just write the code and logic of the application, and it will be less complex, and we can increase the level of automation. Of course, the production is very important, so the engineers' resources is the most expensive. If we can reduce the cost in this aspect, then it will be very important for IT industries and also traditional industries. And second is about the surface. If we can make it more elastic and to increase the granularity of these services, then it would be better. If we can put more containers on that, then we can utilize the containers, which means we can reduce the costs. For a large company like the Jingdong, I think the utilization improvement will make a huge contribution to the cost reduction. Therefore, I think the FaaS will provide benefits for the complexity as well as the utilization. And it is also an event-driven model, and it will be simplified.
The platform can handle everything. Because of the granularity and the flexibility, resources scheduling, it has a huge potential to increase efficiency of resources. Also, in the public cloud, for example, in AWS, the users have some cost issue. However, if for us, like internal cloud platform, we really care about these two issues. I would like to summarize a little bit. For JD, we are one of the earlier adopters for the container and Kubernetes. We have very powerful and stable platform system. However, whether we can further level up the performance or simplify the process of development, we have a lot of application scenarios that we think we can use FaaS, function as a service platform, or event-driven modes, and very fine granularity and flexible mode. So we can have a discussion how to use the FaaS platform for our platform. We have done a lot of service. There are many open source platforms and projects, and whether it is really suit our platform of Jingdong JD. We have already surveyed the OpenFaaS platform. Is this a ready platform for enterprises to use? We found there are a lot of pitfalls because this is a very new technology. In terms of the cloud, we found many mature technologies, for example, AWS Lambda function. However, the AWS has some specific operation models. We are an ecosystem, and we have the F3 and DemoDB. We have our own ecosystem. We're also thinking how to use the FaaS platform to integrate with our own ecosystem. Based on that, we have already implemented some of the FaaS, and we have done a lot of work on it. For example, the system name is called Fibonacci. Fibonacci is the name of the function with many functions. For IT and computer science, the function is very famous. I would like to hand over to my colleague, Tong to introduce JD's Fibonacci function as a service platform and the details. Now let's welcome him. Hello. Mr. Chen Bo has introduced a little bit some of our JD's function as a service platform and its use cases. And now I'm going to talk about some of our practice and experiences when we use FaaS platform. As I've mentioned, JD in 2014 started to do this container work. We have been in this area for many years, so we are quite successful. Our proportion of containerized is very high. All the applications can be now implemented and deployed on the containers. Only those AI cannot deploy. Well, AI can deploy on the containers. For Fibonacci, the function platform initiated this year in August, it was officially launched. The reason why we want to do it, because for so many years we have been involved in container services, we found there are a lot of segmented information. Although this is a container after distributed, the physical node has some storage that is unused. We need to take full advantage of it. For a container platform, sometimes you distribute some default applications, and some of the applications cannot use so many resources. When they use the resources, the usage rate is actually very low. So for the infrastructure architecture, we need to reuse the segmented resources. There is actually a demand for it. From the perspective of business, JD, over the past 3 years, we have already evolved from our e-commerce logistics to some new businesses, for example, offline stores, also video games. Those emerging businesses also adopt new microservice architectures. The business can be deployed in a faster way and also has a very new and faster response. That's why the services are segmented into the micro level. The function FaaS platform is more suitable for this new business. On this open source platform, we have done a lot of things. First is we have enriched some of the features. We want to make it like a whole ecosystem function platform. Also for JD businesses, we have also integrated some of the basic resources into it. We have also done some function template for some of our businesses. Also, for our JD's customized KPIs, we have also done some scheduling and optimization of the resources. So this is a very simple working mechanism or workflow of the FaaS platform. The developer has already abandoned ID and coding or upload the codings to this platform. And this function can be transmitted to our function cluster. The triggering is actually done by API or in many other ways to execute. When we call it or invoke it, it will be executed. Without calling, it will not be executed. This one is our Fibonacci public architecture. On the bottom is our JD KPS container. On top of it, we have middleware, we have JQ and RPC service, and JAD. This one is storage, this one is object storage. On top of it is our Fibonacci architecture. First of all, it could provide a very comprehensive control plane, including the triggers, because all the functions involve the triggers to invoke all the functions. So this is like a trigger management. Also, it is a monitoring management to monitor the execution of functions, also for the launch of the functions and also the coding of the functions. Also, we provide a template function. For JD, internally, we have a lot of technical teams, so we can provide them, if we provide them with public templates, it cannot satisfy their needs. So we can offer such a template management system for the custom template for those technical teams. And also we have online testing platform instead of local testing platform. For all the functions, it will be triggered by the triggers. The trigger has a triggering clustering management. We have some scenarios, for example, app triggered, and the function will be executed. Also, we have a double RIPC service. We also have JMQ trigger. We also have timer trigger. The trigger will invoke the detailed functions. The functions are running in the function clusters. It is composed of several parts. The first one is a basic environment for the function we call function template. On top of it, we have a function safeguarding management or function watcher management for invoking and for execution of the functions. The watcher will be an executor. Also for the developers, they will have the custom function, they will have function monitor, and etc. And this one is also the monitoring cluster. Our JD Fibonacci, we have Prometheus monitoring cluster to integrate all the operations, runnings, alarms, alert, scale manager, rule manager, and alert manager. Those services are actually connected with our other Fibonacci services. The Fibonacci requests for all the services will be done by the monitoring clusters. Another one is our template service. In the template service, we have all kinds of templates for the generic templates, for the custom templates for our colleagues. I've mentioned the trigger. Now, function invocation will be done by function triggers. There are several functions for the triggers. First of all is the request dispatching. Second is collecting the runtime data. The third is access control. And the fourth one is extensibility. Now we provide HTTP, RPC, Q, and synchronize APP. APP can choose either of the triggers to trigger the functions. And the functions have no direct relation with the triggers. When we define the functions, we can choose which triggers to trigger it. And the triggers receive the request of the events, and it will be evoked by the watcher program for the detailed functions. In this chart, from trigger to detailed functions, there is actually a watcher program, HTTP service, to respond the request from triggers. The watcher program does many things. First of all, they translate the request to the data for the function. Second, the context and also the event driven, they will transmit the the data to the functions. And third is about function call. In our practice, we have two kinds of executions. The first one is the watcher program receive the request, and they will use Python, like use the process invocations for different cases. So they will call the functions by the process. The second, they will use Java to trigger it, because Java has a JRAM. If you request first and then trigger it, it will take a long time. So the watcher program, after it receives the request, it will trigger it directly. This is for different cases, maybe depending on the languages and the scenarios. For low frequency cases like a timer, we can use it, because when you call it, you can save some of the resources, and it doesn't have any requirements for the latency. Second is for function upgrading, function logic upgrading. It also has some advantages because it doesn't have any warming loading issues. The watcher program needs to complete a warming loading like a Java. In different scenarios, we can choose different trigger approaches. This one is the watchers. Here are some approaches for the watchers. For example, the function execution, the heartbeat for health check, and also port update. Here it has a ready. Ready is like checking the functions whether they can provide services or not. Maybe some functions has heartbeats, but it cannot provide services. so you can change it accordingly. Also, the Prometheus node exposure, we can collect some of the function data from Prometheus. Now the function platform supported the hot update within a limited restrictions. Here has a circle chart, has a chart. This is the process of the hot update. If you have a request for hot update, you need to make the function an unready status and then fetch the codes for updated functions. For example, the function segment is short, it can be transmitted directly, or it can be just sent directly to you as a file, or the file has already been hosted in your containers. After you fetch the file, you can establish your function logic for replacement and make it ready and to answer the request. Sometimes you don't have to do the hot update, but this is a limited restrictions to make that your logic is very clear.
So we just mentioned the mechanism of the hot update, and we mentioned the categorization of the function containers. We usually divide it into 3 layers. We call the third one we call it function template. So it is a customized template according to your language and your need. And this one is fixed, and we need to deploy it. And the second layer is a function dependency, including the base. You don't have to conclude it in the image. And usually we will just put it in the external storage, and we'll use it after the function started. And third one is a function code, and it is usually a Python file or a Go file. It is very flexible, and we store it in etcd or in the environment variables to do the update. And therefore, when you initially release it, it will be relatively easier. And if you want to do the hot update, you don't have to make the image again. You just need to find out the node containing this container, and then to update it. And this one is about the monitoring. This diagram is relatively simple. As I mentioned, we usually depend on the Prometheus. Why it can do a very good job in optimizing the scheduling? Because the trigger of the function and the execution of the function is controlled by the basic logic of the function. And therefore, the monitoring can be as deep in the business. In the past, if you only use the basic Docker, then you can only monitor the CPU or the machine. But now, you can monitor the trigger, like the timeout or the failure, as well as the replicas. And in the function, we can monitor the whole CPU and the load of the container. And then you can even open part of the API to expose some API of the business. And all of this will be gathered by the Prometheus, and we will handle it according to certain rules. And I'll give you a very small example. It is about request of the 50 KBS. It is a condition for the capacity expansion. So what I'm trying to say is that the function is very visible in the expansion because you can monitor it at a very fine granularity. And this is about scheduling optimization. And this is a recent achievement of our company. And actually, it is a deployment of a pool. And for the function computing, even for a very small function, you still have certain requirements for the start. If you want to do the code start, it will still require a longer time because you need to make an image and then to call the image. Still takes some time. As I mentioned, and we can do some warm deployment. This is a diagram. We have a pool, a concept of pool in the cluster. There will be several pools based on the type of the business. And in the pool, there are some initialized pod, and I think pods usually are templates. We keep all these templates, and when we release it, there are some applications which will have a low requirement for the latency, and then they will send request to the pool. The management of the pool is like the management of the thread pool. It will do some recycle and reuse these resources. If the resource is not enough, they will create new pod. And this is a process, a diagram contain more details. As we all know that before the pod there will be a service as exposure port, and usually the service and the pod will be connected. And we will have the management of the pool. Actually, it's just for managing a set of pods. When we receive the request, for example, the request for new deployment or expansion, and some of the pods will be selected. This is at random. And after we select these pods, maybe they will push it through the codes. And after load all those files, and they will change the label, and then we'll add it rapidly to the function service. Ideally, for Python is very fast, as you can just push the code very fast, and you can just change the parameters of the pods, and they can finish it. And this is a function template customization. And when we just released it, our team said that the template is not good enough. We have more requirements, and we said if you have a requirement, you can tell us, and then we will make it. And now we will just we set up a standard for the function image. And therefore, the other business teams can release their own templates. So there are three parts. The first one is a basic template. You have a very small environment, and we will install some of the core APIs, and also the static dependency that are needed. And for the technicians, they will add the dynamic dependency. So they will install the dependency they want, and also the function configuration they need. But this is still in the customization stage, and after finish the customization, and the container will be started. So there are some dependencies. At first, they are static, and you want to update your dependency. Then we will just post it on the CFS, and then in the future, when you want to update it, and we will update it remotely. So this is about security mechanism. About usually for the code scan, because we have some compliance standard. And originally you upload your code to the Git. You also have the code scanning, but now maybe we just store some of the code, a small section of the code, the code snippet, and then you can't you can't scan it. So now I think now the function code scanning is available for Java and Python. After you scan it, then it will be uploaded and released on the platform. And we also have the test, and also have a control. This is a whole set of the security mechanism. And last part, I have told you all the details, and I want to summarize it. The platform is for solving the problems in the JD.com's business, because the JD is developing fastly. Therefore, we need this kind of service, function service. Want to provide a full life cycle function management from the development to operation and monitoring, and focusing on JD's scenarios. We will integrate with the middleware and also underlying services, and want to support multiple languages in addition to Java. In the past, JD usually used Java for the middleware, and therefore it would be difficult. And now our platform have the triggers, and these triggers will help you to convert it. And we also have a JDOS. It is deeply integrated with JDOS and other middlewares, and also can store it in the GMDB, CFS, and the witness database. And it can optimize the performance and as well as elastic scheduling. Okay, now that's too much. Now I also tell you about the security. And now I'm going to introduce the specific use cases. Okay. Thank you, Tong Xin. So if you are interested in this, you can communicate with us after the presentation. We have some specific use cases like intelligent speaker and also some intelligent image processing, as well as the application in the mobile end. So this is our application. Of course, we want to have communication with the community, and if you want to share if you want to communicate with me, maybe we can just talk after this presentation. Thank you.